All right, now let's start seeing what happens if the region that we're interested in goes below the x-axis. And how does it actually relate to our definite integral? So in this first graph here, the region is just fully above the x-axis. So this is what we've already seen. So we have this region that's under the curve, and the graph of our function here is above, or maybe on the x-axis, but mostly above. So we've already seen this, and what our definite integral calculates, the integral from a to b of f of x dx, it just calculates the area for that region. Now what about if we have this region that's below the x-axis? So the key word here is above the x-axis. But what happens if our region is below? What does our definite integral actually calculate in that case? So the key word there is below. Well, we're still going to be interested in the definite integral, but what this is going to calculate, it's still going to be related to the area, but now it's the negative of that area. So if we were to integrate our function, f of x, from a to b, and the entire curve is below the x-axis, we'll get the area for this shaded region. It'll just be negative. So if our region is below, then the integral calculation is going to be negative. It'll be the negative of that area. Now, what can happen in the most general of cases is we might have our graph, and part of the region is above the x-axis, part of the region is below the x-axis. So this is the most general of the cases here, where we have the region is partially above and partially below. So we have this section that's above the x-axis right here, and then we have this section that's below the x-axis right in here. And so it's still going to be interesting to calculate the integral, the definite integral from a to b of f of x dx. But what does this definite integral actually calculate? It calculates the area that's for this region that's above minus the area for this region that's below. So if we're integrating, if we just have some general function and we integrate it from a to b, what this definite integral represents is it represents the area for the section of our curve that's above the x-axis minus the area for this region that's below the x-axis. So it's the area above minus the area below. And so because this type of value occurs so frequently, we give it a special name. We call this the net area. So if we generalize, if we let f be any continuous function on the closed interval from a to b, well then this definite integral from a to b of f of x dx is the net area, represents the net area. So it's the area above the x-axis minus the area below the x-axis. So this is the most general of cases. If the region is fully above, then our definite integral is just the area. If our region is fully below, well then the definite integral is just the negative of the area. And if we have sort of parts of our region are above and parts of our region are below, well, when we actually do the integration, do this definite integral, we get the area for the section that's above minus the area for the section that's below, and we call this the net area. All right. So the question becomes, how do we find the total area for the region between the curve and the x-axis? So if we have this curve here, this general curve where there's parts of it that are above the x-axis and parts of it that are below, here's our function f of x, and let's say we are interested from a to b here. And we want to find the total area. So we're going to be interested in kind of two different area calculations. The net area, which we just saw, and the total area. So the net area is the area above the x-axis minus the area below the x-axis. That's what we just defined. And we said that was just the definite integral of our function. So it's just the area above minus the area below. So it's taking the area for this section and subtracting off the area for this section. Now if we wanted to add these two areas together, that gives us the total area. So if we were to take the area above plus the area below, that would give us what we call the total area. So it's just the total region, the area of the total region there. So how do we calculate that with a definite integral? Well, we can. We just take the absolute value of our function. So it's the integral from a to b of the absolute value of f of x dx. So the net area is the area above minus the area below. The total area is the area above plus the area below. So we're just adding these two areas together. And the way to do that with a definite integral is by integrating the absolute value function. So just a reminder here, the absolute value of f of x is a piecewise function. So it's f of x if f of x is greater than or equal to 0, and it's negative f of x if f of x is less than 0. So we'll see how to work with this in a little bit. And our strategy, well, right here actually, the strategy. So the question is, how do we find the total area? And integrating an absolute value function is kind of difficult because it's a piecewise function. Piecewise functions, we have to split them up accordingly when we go through the integration. And so that's going to be our strategy here, is we're going to find the x values where our function actually crosses the x-axis, or where it intersects the x-axis. Then we'll determine the intervals where our function is above and where it's below. And then we're just going to calculate the area over each of those subintervals. So we'd calculate the area over this interval here. We'd calculate the area over this area here, and then just add those two values together. All right. And the way we actually find the x values where our function intersects the x-axis, we take our original function, we set it equal to 0, and we solve for x. Alrighty. Let's try an example. That's what we're going to see next.